So see, here a current waveform I have taken. So in this question, let's say if this current is following through this switch, this is any power electronic switch. So we have to calculate the losses in the switch, and on state resistance of the switch is given here. And this is the current waveform which is following through the switch. So one cycle is 15 microsecond, and this is a sinusoidal waveform. So this will be some function of sine omega t. Okay. So can anyone tell me like how we can calculate the power loss since here resistance is given and current waveform is given? So which we should collect? We can collect RMS or average, like IRMS square or I average square into R. What we should select? Can anyone tell? What should be the value? Like we have to take RMS or average. Like power is I square into R. We know P is equal to I square into R. So
Yeah,
what should be
RMS.
RMS? Okay. So see, if voltage drop will be there, no? So what already power equation I told you, P is equal to average power, P is equal to 1 by T V into I into dt. Okay. So since what is the this is the current waveform, so what will be the voltage across this switch? That also will be in variable only. That will not be a constant. So if both things are variable, then we will use the RMS. So let's say here device drop will be given. So it means that voltage is constant. So what we can do, if device drop will be given, so drop we can take outside. So what will be the another term? Another term will be 1 by T into I dt. Okay. So for device drop will be given, we will take average of the current, and here if resistance is given, so resistance what we will take? We will take the RMS value of the current. So here we have to calculate the RMS value of the current, and what will be the power loss? Power loss through the switch will be IRMS whole square into R. So I will give you some time, uh, and for 1 minute of time you can try. Like, otherwise I will explain the short trick also for this one, and we'll go by basic method also. Anyone know short trick for this question? Like what will the value of u? Already u I have defined as u. RMS already I taught in last class. You can refer the last videos. RMS is equal to I am defining u for different kind of function. Okay. So u into d. D is the duty of that waveform. So here what will be the duty of this waveform? Can anyone tell? What will be the duty of this waveform? Can anyone reply? Okay, see.
05 by 20.
No, no. See, here it is starting again. One cycle is here up to here. Here it is starting again. So what is the one cycle? One cycle is 15 micro. Okay. So duty will be 5 micro by 15 micro. So it will be 1 by 3. Duty will be 1 by 3. Okay. This is sine omega t. Let's say 100 sine omega t. This function is 100 sine omega t. Sinusoidal graph. 100 sine omega t. Anything. Should I solve it or anyone can reply? See, I'm directly writing here. Actually, the value of u. U for this kind of wave that I will derive also. U will be this peak value b or I. B, let's say this is if this will be v, so b square by 2. Okay, if this will be I, you will be is any magnitude whole square by 2. So this thing I'm going to derive. Okay, let's say one waveform we are taking. So this is total time period t, and I'm taking 0 to t1. Let's say this is t1. Okay, and Vm sine omega t. So what will be the RMS value for this? This is for conducting for t1, and total time period is t. So I'm going to calculate the RMS value. Okay. So RMS is 1 upon t 0 to t1 Vm square sine square omega t d omega t. Okay. So this will be, finally we can simplify this as, let's say I'm going to the next page. So it will be Vm square by t. Okay, and remaining term sine square omega t we can write as 1 minus cos 2 omega t by 2. So 0 to t1 1 minus cos 2 omega t by 2 into d omega t. So this 2 I am taking outside. So it will be Vm square by 2. Here it will be Vm square by 2. So 1 by 2, what will be the integration? It will be 2 I am taking outside. So it will be 2t. And here 1 is there. So 1 integration will be omega t only. So it will be t1 minus 0. T1 minus 0. Okay. This will be t1 minus 0. And this will be minus cos 2 omega t. So it will be minus 1 by 2 sine 2 omega t. Okay. So here we can see that at 0 and at t1 values are same for this waveform. Okay. So what we can say here? We can say that this value will be 0. So what will be the final value? Final value will be Vm square by 2 into t1 by t. So what is this factor? This factor is the duty. So we can say that what will be the RMS value? U, what we can say that U will be Vm square by 2 and RMS will be U into D. So this will be the RMS. So I have already taught you U for different kind of functions. So this also you have to remember. If sine wave will be there, either will be positive or negative for any duration. Let's say this is some duration is there. Let's say 4 microsecond. And here 1 to 2 microsecond, 1 microsecond to 2 microsecond. If some sine wave is present or cosine, any wave is present, for cosine also it will be same only, you can derive. So for that, either it will be positive or negative. What we can do? We can calculate the U as U is equal to pk square by 2. Let's say if some peak will be there. So for this value, what will be the RMS? RMS will be, let's say peak is K. So RMS will be K square by 2 into what is the duty of this waveform? This is 1 micro. So it will be 1 by 4. Final RMS for this waveform will be this one. Is it clear to all? So any big waveform will be there. Out of that, some portion will be sinusoidal waveform. So you can directly write this U and U into D. Is it clear to all? Or I should explain again?
Sir, why sir 1 by 4 you wrote?
See, 1 by 4 means duty of this waveform. Duty of this waveform. This is the waveform. It is present for 1 microsecond to 2 microseconds. So total duration is 1 microsecond. What is the time period? Time period is 4 microseconds. Again, this waveform will repeat. Okay. This is repeating
Okay,
waveform. So the duty of the
understood.
waveform will be 1 by 4. Is it clear?
Yes, sir, understood, sir.
Should I again explain this derivation? Like how I have calculated the U value for this
For
kind of
any sine wave, you can calculate this root over unity.
what you are telling? Can you tell again?
For any kind of sine wave,
Yes, yes, any kind of. Let's say
with different duty cycles, we can get
uh,
same RMS
yes,
by
yes,
this formula.
same only, same only. You can calculate manually also. See, either it will be shifted or it will start from here. The whatever calculation we are doing, that will be same. Okay. See here for a normal derivation I have done. So sine wave is presenting for this one t1 time t1 time. Okay. Total cycle is t. Again this sine will start from here. Okay. So for this only I have derived this equation 1 by t 0 to t1 bm square sine m square omega t d omega t. So what final we got? Final we got this value Vm square by 2 into T1 by T. So T1 by T is the duty. Okay. This you can verify manually for any waveform. Let's say another I am drawing. Let's say this is a waveform. Okay. This is total time period. And here any sine or cosine we are getting. Let's say sine or cosine anything. It will be same. You can derive it. Okay. Let's say this is available for T1 duration. A small T1 duration it is available. So what this is, let's say K. So here also, what will be the RMS value? RMS value will be under root U value. U is k square by 2 for this kind of waveform into duty. Duty is T1 by T. Is it clear to all? Any question you can verify by manual method and by this short trick also.
Clear, sir. Clear, sir.
Clear. Okay. So you can refer the previous video for different kind of U. For other function also I have given the different U, different kind of function. Those who have not gone through that content, you can refer the previous video. Okay. So based on this only, I am going to solve another question. So this is the next question. Okay. So here it is a combination of different kind of waveform. What is the time period? Time period is 8 micro. Okay. Time period is 8 micro. And here this is a sine wave. Sine or cosine, anything. It is sine or cosine. Sinusoidal is telling me sine or cosine. Okay. What is amplitude here? Top is here 10 and below sine peak value is 5. So we have to calculate the total RMS value of this signal. Okay. So can anyone tell just what steps we have to follow to solve this question? How we can solve it? Just a step. What we can follow?
First, trapezoidal waveform is split
Okay.
into three areas, sir.
Okay, 3 areas. So here first, this is second, and this is
Yes.
third. Okay. So these 3 areas are there, and this is fourth one. So total
Yes, sir.
four we have to do. E1
For
into D.
RMS value of 1, RMS value of 2, RMS
Okay.
value of 3, RMS value of 4.
Okay. 1, 2,
2,
this is 3,
3,
and this is
and
4. So first we will write the duty. What is the duty of waveform 1? What is the duty? Can anyone tell? Total time
1
period.
by
So
1 by
first duty will be 1 by 8. Okay. What will be the duty of second waveform, second signal?
1.5 by 8,
This will be 1.5 by 8. And for third one,
1 by 8,
it will also be 1 by 8. And fourth one will be
3.5,
it's 4.5 to 7, so it will be 2.5.
2.5.
2.5 by 8. Okay. We have calculated the duty for all 4 waveforms. Is it clear? Now we will calculate the U value. What will be the U? So what will be the U for this first signal?
Half into 10 into
10
1 by
square, 10 square by 3. This is just a triangle. We can apply that also 1 by 2, 1 by 3 into b1 square plus b2 square plus b1 b2. But here it will be 10 square by 3 for this triangle. Is it okay?
Yes, yes.
For this one, what will be the value for second waveform?
How sir? 10 by 3.
See, already I taught this is the short trick. For any triangle, actually you can refer my. Have you attended my previous classes?
No, sir. Do some personal issues.
Okay. I will share the link of the otherwise in NPTEL website also there, but I will share the link to you. Okay. Are you there in NPTEL? One group is there, WhatsApp group you are there.
Which WhatsApp group, sir?
Okay. One second.
I am present in one WhatsApp group. That's NPTEL some.
Network analysis. Are you there?
Yes, sir. I am there.
Okay, okay. So I will share the link there. You can watch previous videos. Okay. So I have defined U value for different kind of waveform. What will be the value of U for triangular waveform? What will be the U for different kind of waveform? So for triangular waveform, see here for sinusoidal waveform, what I have derived? What is the U? U is peak square by 2. Okay. Similarly, I have written the U for triangle waveform. So triangle waveform, what will be the value of U? Peak square by 3. Okay. For constant, what will be the value of U? It will be peak square. So for this one, constant from here to here it is constant. Here to here it is constant. So it will be 10 square. Here U will be 10 square. For here also triangle is there. So it will be 10 square by 3. And here sine wave is there. So what will be the value? Here 3 it will be.
10.
And for sine wave it will be 10 square by 2. Is it clear?
Sorry, area of the 3, 10 square by 3, sir. 10 cube.
What you are telling?
Oh, yes, sir.
See, you can refer my
Triangle.
previous video, na? And then it will be more clear. Okay.
The third region, sir, is
Third
same.
region also see, third region also triangle only, peak is 10. So
Here
10
you
square
wrote
by 3,
here
sir. That one.
10 square by 3,
10
sir.
square, okay, 10 square by 3. By mistake, I have written there. Okay. So for this one, RMS what will be? Multiply and under root. So total RMS will be RMS 1 square plus RMS 2 square plus RMS 3 square plus RMS 4 square. So what is the RMS? RMS is under root U into D. D is here, U is here. So under root U into D, if we will do the square, what will be that value? U into D. So we can write as U1 into D1 plus U2 into D2 plus U3 into D3 plus this will be U4 into D4. Is it clear?
Yes.
So here directly we can write U1 how much? 1 by 8, 10 square by 3 into 1 by 8 D1. Okay, plus 10 square into 1.5 by 8 plus 10 square by 3 into 1 by 8 plus 10 square by 2 into 2.5 by 8. So this will be the final RMS value. Okay. This will just, if you will remember this trick, it will take just 1 to 2 minutes to write this equation. So in GATE also this kind of question they are asking, but if you are going by basic method, that will take more than 10 minutes. Okay, you will write the equation of this one, again you will write this one. But if you will follow this short trick, it will take more, it will not take more than 2 minutes. Just you will write the duty and the U value, directly multiply it and take the square root. So can anyone calculate this value? What will be the final value for this one? I am also calculating parallelly. So 10 square by 3. So these two we can take common. See here. This is 10 square by 3 into 1 by 8. This is 10 square by 3 into 1 by 8. So 1 by 8 plus 1 by 8, it will be 1 by 4. So we can write it 10 square by 3 into 1 by 4 plus second term is 10 square by 10 square into 1.5 by 8. 10 square into 0.5 by 8 plus 10 square by 2 into here it will be 2.5 by 8. Here it will be 2.5 by 8 into 2.5 divided by 8. So final value, can anyone have calculated? So final I am getting as VRMS is equal to 6.535 volt.
VRMS equal to 6.535 volts.
Is it, everyone is getting this value? Okay. So all of you should remember. See, for triangle 3 4. Should I give one revision of this formula now? Should I write once? If all of you will tell, I will write that formula again. I'll do the revision one. See, why I'm writing U for different kind of waveform. Okay. So let's say first is constant. Any constant value will be there. Constant value. This is time period. This is the duty of the waveform. Okay. This is the duty. So for constant value, what will be the U value? U is equal to, so this is constant. So U will be K square. Okay. Second kind of waveform, any triangular waveform. Let's say it is this kind of triangle, increasing triangle, or let's say this is duty and this is time period. Either it will be a decreasing triangle. Let's say any time it will be a decreasing triangle, duty will be D and time period will be T. So another kind of triangle will be rising and falling, both will be there. It will be D. Okay, and time period will be T. So any type of triangle is present for a particular duty, what will be the U value? Let's say this peak value is K. So U will be, all peak is K. So U will be K square by
K square by
3.
3.
Okay. Third kind of waveform is, let's say it will
Hello.
be a minimum and maximum value. One have doubt? Okay. So let's say it
Sir,
is
in this particular case,
okay.
sir,
So
sir,
one
in
thing
this,
I'm telling here, if it will be negative side also, this will be same. because we are calculating RMS. RMS a square will be happening. So if triangle will be negative side also, it will be same only. If this constant will be negative side also, you will be same only. Ask your doubt now.
Sir, this triangle you have made this K,
K is the
this third number.
every
Sir, third
amplitude is
number.
K only. This is the axis. Okay. See, during 0 to t, if any duration it will present this kind of triangle. Let's say triangle is, this is the time period and our triangle is present here at middle. Okay, this is the triangle, this is the duty. Okay, and peak is the K. This is the total time period. Okay, is it clear?
Yes, sir.
Okay. So duty means, again I am defining, duty means the time duration for which the pulse will present. So again I am writing duty means T by total T. What is the T? T is the duration of that particular pulse. This is, let's say this is triangle, so this will be T. So duty will be a small t by capital T. Okay. Again I am writing for another kind of waveform, so that will be like some minimum to maximum it will go. Either it will be this minimum, let's say I or B minimum. I minimum I am taking or I maximum. Okay. Either it will be this kind rising or this is
Sir,
to, yes, you can ask. Yes.
in second case, how you write U is equal to K square by 3 means where the value 3 came from?
You can derive this. Okay. You can see, you can take any value and you can apply this formula. Whatever the short tricks I'm telling, just I have derived here for sine wave. Here I have derived this trick for sine wave. Similarly, you can derive, you can take any triangle, let's say, for your, you are asking, I will derive one. Okay, let's say we are deriving for one triangle. Okay, just one triangle. So this is a triangle. Okay, this is time t and this is total time t. So what will be the equation of this triangle? Can anyone tell? Let's say this is K. So what will be the equation of this triangle? Y,
KT,
y minus
K2.
y1. See, this is x1 y1 x2 y2. So y minus y1, y minus 0 is equal to y2 minus y1 divided by x2 minus x1. So it will be uh,
K, K,
k by
K by
t
T. No, K by T.
into
K by
t.
T into T. Into
So what
capital.
will be?
K
One
by
second.
T into capital T.
1 second. What is let's say this is t1. Okay. Let's say this is time axis and this is t1. Okay.
Okay.
So k by t1 into t. Is it okay? K
Yes,
by
sir. Yes,
t1.
sir.
So we can integrate it. Okay. So k by t1 into t whole square. This will be 1 by t. This one it will be into dt 0 to t1. Is it clear? This will be the RMS value. Can anyone tell?
yes,
Is it
sir.
okay? So we can simplify. So what will be the value? This will be k square by t1 square. So k square by t1 square, we can write here k square by t1 square into t. This will be the constant value into what will be this value? T square. So tq by 3. Is it clear?
So there is a T1, sir, upper limit.
What? Should I write again?
Huh. 0 to T1, sir, limit.
This is T1. Okay.
Yes, sir.
So this
Now
will be
that is
finally it
answered.
will be T1 by 3, T1 Q by 3. Okay. Is it clear?
Yes, sir.
So see T1 Q by T1 square, what will be this value? At top it will be T1. Na? So we can write as K square by 3 into T1 by T. Is it okay? Is it clear?
Yes, sir. Yes, sir.
So same thing I have written here. So what will for any kind of triangle you can do this calculation. Okay, any calculation manually you can do. So what you will find u into d. D is the t1 by t. So u whatever I have written here k square by 3. Now is it clear?
Yes, sir.
Okay. So this
Yes,
I
sir.
have derived the short trick. You can do any manually calculation question, and you can verify with this short trick. Both answer will be matching. Okay. So for next this waveform also you can derive whatever short trick I am writing here. Say I mix minimum, I maximum. Okay. Here I maximum, I minimum, I minimum. Here also you can write the same equation of the line you can write, and you can verify the final formula. This is total time period, this is total time period. Okay. This is second kind of waveform. This is third kind will be rising and falling. Okay. Here also maximum and this is minimum. Okay. This is duty. So for this, what will be the value of u? U will be 1 by 3
1 by 3 into I
I
minimum
minimum
square
square plus I
plus
maximum
I
square
maximum square
plus
plus
I
I
minimum
minimum into I
to I
maximum.
maximum. Okay. This also you can verify by doing the straight line equation, and all calculation you will do, you will find same only. Okay. So on fourth kind of waveform, I already told if sine will be present anywhere, it will be peak will be there. Let's say this is k, this is t. So what will be the u? U will be k square by 2. Is it clear? So if any
Yes.
combination of this waveform will come, you can apply like this one, whatever I have told here. I think it will help you all. So should we move to the next question, or any doubt is there?
Sir, next slide, one doubt, sir.
Okay,
Next slide, sir.
okay, I'll move. Okay,
Sir, here in the third point, third one, sir. Third
okay,
one graph.
this one.
Yes, sir. Two minimum points is there, no, sir.
No, minimum both minimum are same only.
Okay, sir.
Let's say like in DC converter, if we are going, so inductor current somewhere if you will draw, it will go maximum and minimum. So inductor current shape will be like this one. This both minimum will be same and maximum will be same. This is one duty cycle. So if it will be asked like what will be the inductor current, so inductor current duty will be 1. This is total time period. This is on time, this is off time. So directly we can put duty as 1, and we can put, so we can calculate this kind of waveform. No need to put in two parts like part 1 and part 2. Directly we can do like this one. Is it clear?
Okay, sir.
Okay. Okay. So I'm moving to the next question. That is a two-port network question, I think I have taken. So this question I'm going to apply another kind of method. Like first I will draw the circuit for this two-port network. Already one question I have explained for GATE 2023 question I have explained with short trick method. So here I'll also go by that method. So what is the two-port network equation? First I'm going to write. So V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. So this equation we can write as, like let's say this is V1. So this we can write as Z11, and this will be plus minus Z12 I2. This will be the port 1, and what will be the port 2? Here it will be plus, here it will be minus. So Z21 I1, and here it will be Z22. So this two-port equation we can write like this. Is it clear to all? Same equation I have written here. So this is I1 is coming here and I2 is coming here, entering here. So V1 we can write, let's say this is V1 and this is V2. So if you apply KVL here, we can say that V1 is equal to Z11 I1 plus Z12 I2. And what will be the V2? V2 is equal to Z21 I1 plus Z22 I2. Is it clear to all? Just this equation I have written in this network form. Is it clear?
Yes, sir.
Okay, so same network I am going to draw here for this one. So Z11 40 already given there. So here I can write as 40 here, and previously 10 is there. So here it will be 10. Okay, and what will be here? Plus minus. What is Z21? So it will be 60 I2, and here it will be plus minus. What it will be? Here also it will be 60 I1, and this resistance will be Z22, so it will be 120. Okay, and here 120 volt source is given. Okay. So now this simple circuit is there. We can solve it easily. So what it is asking, what is the value of ZL for each maximum power transfer to the load? Okay. So for this kind of question, if dependent sources will be there in the question, what we can do, we can supply either one external voltage source or external current source, whatever will be convenient. So what I'm going to do here, if we are supplying external current source, so in that case, what we have to do, we have to remove the whatever the source present will be in the circuit, that we have to replace by their internal resistance.
Short
So,
circuit would be 120 ohm,
so
120 volt.
here this internal resistance will be zero, so it will be sorted. So I am sorting here, and here I am just supplying a 1 ampere current source, 1 ampere current source. So here we have to calculate the voltage V. Okay. So see, this is I2. Okay, this is I2. So what is the value of I2? 1 ampere. So this will be 60 volt. Okay, and this is I1. So can anyone tell what will be the value of I1? Can anyone
I1
tell?
equal 60
I1,
by 50 amp.
I1 is equal to, so it will be minus, I1 is equal to minus 60 by 50. So it will
Minus
be,
1.2 amps.
okay, so it will be minus, like I'm writing here, minus 6 by 5. Okay, so we can calculate V1 here now. So 60 I1, how much? 60 into I1 plus 120 I2. V will be, V is equal to 60 I1 plus 120 I2, I2 1 ampere, so plus 120. So 60 into minus 6 by 5 plus 120. Can anyone simplify this? What will be the value of B here? So 5 into, so minus 72 plus 120.
48, 48.
Okay. So this V is 48. V is 48. So what will the value of Z? Z seen by this one, V by I. Okay. So V 48 means what will the value of resistance? R
48.
is equal to 48 divided by 1. So it will be 48 ohm. Is it clear
So
to all?
how you write the value of 1 ampere?
See, anything we can do. See, if independent, dependent sources will be there in our circuit. So what is the method to calculate the Thevenin's resistance? We will just provide either a voltage source or current source. So what is the Z? Z will be V by I. Anything we are injecting in the certain circuit, either if we are connecting here voltage source, so we have to calculate current here. And what will the value of Z? Z is equal to V by I. So here I am applying a 1 ampere current source. So what will be the voltage here? So we'll divide by this current 1 ampere. So R will be 48 by 1, it will be 48 ohm. So this is the method. Like if in our circuit, if dependent, this kind of sources will be there in our circuit. So in that case, what we will do, we will supply a external voltage or current source, whatever will be convenience. So here I thought that current source, like applying a current source will be easier. Okay, so I applied current
Sir,
source.
but how do we choose the value of current? Means I don't get the
Any
this concept.
anything you can select. Let's say if I am selecting I also, I will get the same answer. If I will select a variable I also, I will get the same answer. You can try that. Okay, 1 ampere, why
Okay,
we are
sir.
selecting? Because this will be the like easier, like R, this V I will get more. Okay, if I am selecting this any other current, this V I will get more, and then finally I will get 48 only resistance. Okay, why one we are connecting? Because calculation will be simpler, because 48 by 1 is equal to 48. Is it clear?
Okay, sir.
See, if you will connect more ampere of current, you will get this voltage more. Okay, let's say if you are connecting 2 ampere, so you will get here 96 voltage. This voltage you will get 96. Final will be 96 by 2, 48. Is it clear?
Okay, sir. Okay.
Okay. So same question I am going to calculate the Thevenin's voltage also. So I'm going to write it on next page. We can calculate the Thevenin's voltage. So this is 10 ohm, this is 40 ohm, that is this value, plus minus 60 I2. This is 60 I2, and here it is plus minus 60 I1, and this value 120, and here it is plus minus how much, this voltage 120 volt. So how we can calculate this voltage? See here this I2 is 0. So I2 0 means what will be this value? This 60 I2, this will be sorted. I2 is 0 means this voltage will be sorted. So what will be the value of I1? Can anyone tell?
2.4 amps.
I1 will be 120 by 50. So it will be
2.4.
2.4. See here current is 0. So what will be the voltage here? V will be 60 I1.
144.
So it will be how much? 144.
144.
Okay. So voltage will be 144 volt. So this will be the Thevenin's voltage. Okay. So to make it simplified for any two port, any like either it will be H parameter, Y parameter or Z parameter, if we will go with this one, like problem will be visible, like what step you have to do next. Okay. You can solve it in less time. Is it clear to all? Should I move to the next question?
Yes, sir.
Yes, sir. Sure, sir.
Okay. So this question is asked in 2023 electrical engineering paper. This is a synchronous motor question. Okay. So in this question, a steady state stability limit of the synchronous motor is given, which is 2.5 per unit, and synchronous impedance of the motor is given, this is 0.1 plus j 0.3 per unit. So we have to calculate the EMF of the motor. Okay. So for any synchronous motion question, what will be the first step? First step means you should draw the single line diagram. Okay. Here, what is the meaning of this stability limit? It is the maximum power transfer capability of the motor. So first I am going to draw the single line diagram of a synchronous motor. So here this is the terminal voltage V angle 0, R, X, and then motor will be there. This is here we are supplying the power to the motor. This will be R, will be Jx, and here will be E angle minus delta, EMF of the motor. So we can calculate the apparent power here. What is apparent power? S is equal to VI conjugate. Okay. So first we can calculate the current from flowing in this circuit. What is the current? Current will be, so for any power transfer question, I will recommend you all, if you are not memorizing the formula, you should apply this S is equal to VI conjugate. So in that case, plus minus confusion will not be there. You see how I am doing. I is equal to V angle 0 minus E at angle minus delta divided by, so this will be Z angle theta. What is the value of Z? Z is equal to under root R square plus X square, and theta will be tan inverse X by R. Okay. So VI conjugate, what is the value of V here? E angle minus delta. So S we can write as apparent power E angle minus delta into I conjugate. So I is V angle 0 minus E angle minus delta divided by Z angle theta whole conjugate. Okay. So by simplifying this, we can write as this will be, so E angle minus delta here, it will be theta will at, if it will go in numerator, it will be minus and conjugate will be plus. So we can write as EV by Z angle theta minus delta minus E square by Z. So it will be theta plus delta. See, theta will go in numerator, it will be minus theta. So minus theta minus delta, and it will conjugate will be theta plus delta, and theta plus delta minus delta, it will be theta. So this will be the final equation of the apparent power at this point. Anyone having doubt in this equation? How I have calculated this apparent power? I will explain again. Is it clear to all?
Hello.
Yes. You can ask.
Sir, when we multiply this E angle minus delta with minus E minus delta, then angle will vanishes.
See what will happen. So this Z angle theta. So without conjugate it, I am doing conjugate. So before conjugate, what will be the angle of this portion? It will be minus delta minus theta. So angle will be minus delta plus theta. But if we are taking conjugate of that, if we are taking conjugate means what will happen? It will be plus theta plus delta. Okay. So plus theta plus delta will be the this part angle, and if we are multiplying by minus delta, so minus delta plus delta will be cancelled, and what will remaining, that will be plus theta. Is it
Okay,
clear?
sir.
Clear? Is it clear to all? Should I move next? Okay.
Yes, sir.
Okay. So see, this is the apparent power equation. How we can calculate the real power? Real power, just we can take the cosine. Okay. So P we can write as P is equal to EV by X, right here, cos theta minus delta, cos theta minus delta, minus this is E square by Z cos theta. So this is the power, real power equation. In question it is asking that a static stability limit. So what is a static stability limit? That is the maximum power transfer capability of the motor. So what is the P max? For P max we can differentiate this equation with respect to delta, since delta is variable and load and impedance is constant, means theta is constant. So here variable is delta. So dP by d delta should be equal to 0. So from here what we can deduct is cosine, what will be the differentiation will be, can you tell what will be the differentiation of this cosine?
Sir, sine theta.
Okay, so it will be minus
Sine.
sine, minus and minus delta is there, so what will be sine theta minus delta, sine theta minus delta. Okay, differentiation of cos will be minus sine, and here minus is there inside, so it will be minus 1, so it will be plus sine theta minus delta, and this differentiation will be 0, so it will be equal to 0. So what we can say from here, that delta is equal to theta. So when load angle will be equal to the synchronous impedance angle, that is the case when maximum power transfer will happen. Is it clear? This equation is clear to all? See, this is constant part, so this differentiation will be 0. This is also constant, it will go in right side, it will be 0. So cos theta minus delta, it will be sine theta minus delta will be 0, and it will be theta minus delta will be 0, so delta will be theta. So when
Okay, sir.
okay, so what will be the maximum power? This will put here. So if you put here, what will be the cos 0 will be 1. So P max will be, P max is equal to EV by
EV by X.
X minus E square. Here Z will be there. I have done mistake. Previously it was Z here. So EV by Z minus E square by Z cos theta. So this is the equation of the maximum power. And what is the given? Given is the P max. P max is 2.5 per unit. It is given here in the question. And Z is given at 0.1 plus Z 0.3. So we can write Z as Z is 0.1 and this is 0.3 Rx. So what will be the magnitude of Z? Z will be under root this square plus this square. So 0.01 plus 0.09 summation will be, this will be 0.1 under root 0.1. Is it clear? So I'm going to put all the data in this equation. Then we can calculate this EMF value. This EMF we have to calculate. It is asked in the question. So we can put here P max is 2.5 is equal to, what is the value of V? V is 1 per unit. So see, normally nothing will be given in the question. So what we can say, that this terminal voltage is 1 per unit, and that we can select. So 2.5 is equal to E by Z. Z is how much? Under root 0.1 minus E square by Z how much? Under root 0.1, and cos theta value from here we can calculate. So cos theta is equal to this 0.1 divided by under root 0.1. Cos theta is equal to 0.1 divided by under root 0.1. So it will be under root 0.1. So here we can write cos theta value into under root 0.1. So this will cancel. So what will be the final equation? Final equation we can write as E square. This I am taking in LHS. So E square minus, so 1 by under root 0.1, it will be under root 10. So it will be minus root 10 E plus 2.5 is equal to 0. So by solving this equation, quadratic equation, we can calculate the value of this EMF. Okay. So just we can apply quadratic equation rule, minus b plus minus b square minus 4ac. So E will be minus b how much? Under root 10 plus minus b square minus 4ac, b square is under root square. So 10 minus 4 into 2.5 divided by 28. So A is 1 to 1. So this will be 10 minus 10, it will be 0. So what will be the final value? E will be
So there will be root no, sir.
what? Can you,
Whole root, sir.
which root? Under root.
Ah, yes, sir.
Okay, anything will be there. This minus this will be 0. 10 minus 10 will be 0. I've done some mistake. Okay, it's correct only. Minus b plus minus under root b square minus 4ac by 2a. So 10 minus 4 into 2.5, how much it will be? 10. So 10 minus 10 will be 0. So what will be remaining? Only first term. So E will be under root 10 by 2. Can anyone calculate what will be this value? So this was a 2 marks question. Okay. Little bit calculation it is required, like little bit analysis. If you have practice, so this equation you can write within 1 minute. This equation from here to
Sir,
here.
1.58, sir.
1.58. Okay. So this only was the final answer under root 10 by 2. So 1.58. 1.58 per unit. This was the 2 marks question. Is it clear to all? See,
Yes, sir.
get 2023 paper, people are telling that it is tough, but if you will do practice, proper practice, see this all questions, whatever I have explained in the previous video also, network, either network or power electronics also, that was easy only. If you will do practice and if you will not do calculation mistake, then you will get more marks only. Okay. So should we move to the next question? Is it clear to all?
Yes, sir.
Sure, sir.
Okay. See, this is also 2 marks question. See how like easily I am going to solve it. This is 2023 question only. So some people will apply some like 2 kVL or 3 kVL. So see how to solve it in like less time. Step by step I will tell you. So see, I am going to apply KCL at this node. This is one circuit given. Okay. So it is asking in the question that what will the voltage here voltage across this terminal at t is equal to 5 millisecond. Okay. So this is not a tough question. It's very easy question. I'm going to apply KCL here. KCL at point P. So what will be the voltage at point P? First we will write. So here we are seeing that Ix current is flowing. Okay. This I am selecting as ground. So what will be the voltage here? Here the voltage will be 10 minus 10J into Ix at this point. Okay. So Vp I am going to write. What is the Vp? Vp is equal to 10 minus 10J, okay, into Ix, and this will be minus 4Ix. So I have written the voltage at node P. Is it clear to all? This voltage I have written Vp. Is it clear? This equation is clear to all? Can anyone reply? Hello?
Yes, sir. Yes, sir.
Okay. So see, now one step I am going to write the KCL. Okay. So KCL will be here. How much current is going? Ix. Okay. Here Ix is flowing here. So I'm going to write the KCL. So KCL will be what summation of all outgoing current should be 0. So let's say this is I1, this is I2, and this is I3. Okay, so I1 plus I2 plus I3 should be equal to 0. So I1 is Ix plus what is the value of I2? I2 is equal to Vp by 10 minus 10J. I2 will be Vp by 10 plus 10J. Okay, this will be the I2 current, and what will be the I3? I3 will be minus I is equal to 0. Is this equation is clear to all? KCL at this point P. Okay. So I'm going to write the value of I. What will be the value of I? Okay. So
Sir, terminals A and B are open circuited, sir.
which one? A and B are open only.
Okay, okay, sir. That's
Yes.
why IX is in series. Okay,
Hmm?
sir.
What?
That IX dependent source will be IX in series, sir.
Okay. See, first we have to write this voltage equation. If we are getting this voltage equation, then we can get the voltage at t is equal to 5 milliseconds. Okay. So see, step by step I am doing. It will be clear to you. So,
Sir,
yes.
Ix should be negative since the voltage source is plus and minus and we are taking in opposite directions. That's why I'm asking.
Which? Can you ask again? You can ask again.
Sir, sir, Ix should be negative. I
See,
I'm thinking that.
what convention I am following? According to me, KCL definition that will be easier to you. See, what is the KCL? KCL is the summation of all outgoing current from a branch should be equal to 0. This I am applying. Okay. So from here at this node, what will be the current going in this side? Since this is open circuit, so this Ix will flow in this way. Is it clear? So this side current will
Yes,
be
sir.
Ix. This side current will be Ix. What will current flow here in below direction? This will be Vp by Vp already have calculated here. So this will be Vp divided by 10 plus 10J. And here
Okay.
since I is following in this direction, so outgoing current will be minus I. Okay. What will be the outgoing current here? Here outgoing current is minus I. Here
Minus.
outgoing current
Okay.
is Ix. And here outgoing current is
BP by
Vp by 10
10.
plus
B
10J.
by 10 plus.
So this equation I have written.
Sir,
Yes.
how did you write BP equation,
Okay, I will
above
explain.
equation?
I will explain again. Okay, 1 second. I will explain again. See, Vp means potential of this voltage point. 1 second. Potential of this point.
AB point,
V
AB
point.
point.
Vp point. So let's say I am connecting a fixed TCS voltage source between this point and ground. Let's say this is plus, this is minus, this is connected to ground. Okay, and this potential of this point is Vp. Is it clear? So
Yes,
this
sir.
this source, like, this is not a voltage source, just a fictitious source I'm connecting here. So we have to calculate this. So we can write case KVL in this loop. Okay. So how we can write minus Vp, okay, minus 4Ix, and this will be plus 10 minus 10J into Ix should be equal to 0. Is it clear?
Clear, sir.
Yes, sir.
See, so here we can write what is the Vp. Vp is equal to 10 minus 10J into Ix minus 4Ix. Now it will be clear. Is it clear? Same thing I have written here. See, here to here voltage is this. Plus is coming here means we have to subtract this one. Okay. This drop from here to here, 0 to here we are seeing. So here voltage will be 10 minus 10J Ix. Okay. If we are going here, so we have to subtract this value. Okay. If minus will be here, plus will be here, so we will add this. Because here it is in negative polarity, so we will subtract this one. So Vp will be 10 minus 10J into Ix minus this 4Ix. Is it clear now?
Yes, sir.
Okay. So see, this one equation itself, now in 1 or 2 steps, we can get the final answer. Okay. So I'm writing the further equations. So this will be Ix. So Vp, how much? Plus 10 plus 10J Ix minus 4Ix divided by, this is 10 minus 10J at top, divided by 10 plus 10J is equal to I. Up to now it is clear to all. So Ix we can take common here. Ix will, if we are taking common, what will be the value? It will be, how much it will be? Can anyone tell? This 4. Can anyone tell what will be the final value if we are taking Ix common? See, here we can see now 10 minus 4, 6. So 10 minus 4, 6 will be there. We can take common here. So we can say 10 minus 4, 6. So 6 minus 10J. Here it will be minus 10J. 6 minus 10J. Okay. Divided by 10 plus 10J. And plus here it will be 1. Should be equal to I. Up now it is clear to all. From this to this. Is it clear? See, Ix I have taken common
Yes,
here.
sir.
Okay. So further we can simplify this equation as, so here it will be, what it will be, 10 plus 10j at top. So 16 divided by 10 plus 10j, it will be ix into 16 divided by 10 plus 10j is equal to I. Is it clear? So what will be the Vx? This Vx is equal to Ix into Vx is equal to, this is the Vx across VAB. VAB we can write as VAB will be what it
Ix
will,
into 10 minus
Ix
J10
into 10 minus J10.
J10.
Okay. So we can write as Ix will be 10 plus 10j by 16. So we can write as 10 plus 10j divided by 16 into 10 minus 10j into I. This will be VAB. Is it clear? Is it clear to all?
Yes, sir.
See, so what will be the this 10 plus 10j, 10 minus 10j? It will be a square minus b square. So it will be 200 divided by 16 into I. I is what? Sine 1000 t. So this is the final equation VAB. Is it clear? So at t is equal to 5 millisecond, we can calculate the value. 200 divided by 16 into 5 millisecond, how much? Sine 5. We have to keep it in radian, I think, here. Can anyone calculate? 5 millisecond into 1000, so it will be 5. Can anyone calculate what will be this value? 200 divided by 16.
0.5, sir.
200 divided by
Sir, it is
16
coming
into
minus
sine.
11.98.
So it value will be, get answer will be same also, minus 11.98 volt. See, simple one line KCL equation, you will reach up to this point, put the value of t, you will get the final answer. So,
Okay. Sir, I have some doubt.
okay, you can ask.
Sir, like they did given this voltage dependent source plus minus 4ix.
Yes.
So this voltage can be assumed this node
Which node?
node A is
This one.
node A.
Okay.
Yes, sir.
Hmm.
It has a voltage of 4ix plus
No,
4ix.
no. This
No.
node don't have a voltage of 4ix. See, this I am taking as a ground. Okay. So with respect to ground, what will the voltage of this node? Can you tell? See, in nodal analysis, we have to select some ground. So if I am selecting this point as a ground, okay, what will be the potential of this point with respect to ground? See,
0.
10 minus 10j into Ix. Here we can write, this is 10 minus 10j into Ix. So plus minus, what will be the value here? This VAB will be 10 minus 10j into Ix. Is it clear? This drop across this resistance will appear here. From ground, if we are looking till now here, it will be voltage. In this way also, if we are looking, voltage will be same only. Okay. So from ground to this point, voltage will be 10 minus 10j into Ix. Is it clear?
Okay, we have to take with respect to ground.
Yes. See, this voltage source is given, not voltage of this node. This is a voltage source is given, not a node voltage is not given here. This is a voltage source connected here. Okay. Is it clear to all? So see here only 3-4 lines we have written. We found the final answer. This is a 2 marks question. Okay. And people are telling that this 2023 is the toughest. Toughest paper also see the level of question. If you are doing like practice, you will solve that in lesser time. So today this much only.
Next question, sir.
You want some more question? Like it's
Yes, sir.
already
Yes, sir.
okay. I will take, if question is there, I will take one more question. So everyone is okay with, should we solve one more question?
Okay, sir. Okay.
Okay, so that is also 2023 question only. See, 2 marks question I am going to solve. You see how much less time it will take. It is looking a very big question. Okay. This is a fault analysis question. So first I will tell you the basics, what we have to consider in while we are going to solve the fault analysis question. So main thing is pre-fault condition. Okay, pre-fault condition. So here it is written that pre-fault currents magnitudes are neglected. So pre-fault are neglected. Neglected means what will the voltage of all buses? That will be 1 per unit. Okay. Here let's say voltage is 1 per unit. So here also voltage will be 1 per. Everywhere it will be voltage will be same because currents are previous to fault current. What we are assuming 0. See, if in running system, okay, system is running, so pre-fault voltage will be different at the fault point. Okay. So it is a double line to ground fault question. So what I will tell you, for every type of fault, you should remember the sequence impedance diagram. Okay, so for double LG fault, I am going to draw the sequence impedance diagram. So that will be, this is plus minus V pre-fault. Okay, here it will be Z1 and here it will be Z fault impedance, and here it will be Z2. Okay. So similar kind of diagram will be there for different kind of fault that you should remember. So this is for LL fault, line to line fault. So for line to line fault, this kind of diagram we have to draw, where this is the equivalent impedance with respect to fault point. So here fault is happening at bus number 1. So equivalent impedance with respect to fault point, we will calculate, that will be Z1. Z2 will be negative sequence. So negative sequence equivalent with the fault point only. So the Z2. And what is the ZF? ZF is the fault impedance between phases. So here it is written that bolted. Bolted means fault impedance is 0. Bolted means it is a solid fault. Okay. So fault impedance will be 0. So for line to line fault, there is no need for information of the 0 sequence. So this extra information they have given, no need to use this. Just to confuse us, they given this extra information. So since line to line fault is happening at this bus 1, okay. So can we calculate the equivalent impedance with respect to this point? So positive sequence impedance, see here 0.2 and here 0.3. So what will be the Z1 equivalent? Z1 equivalent will be 0.2 into 0.3 divided by 0.5. So it will be J 0.12. And Z2 also same, 0.2 and 0.3 parallel. So Z2 equivalent will be J 0.12. So this will be here positive sequence current, IA1. And what will be the fault current equation for LL fault? IF is equal to minus J root 3 IA1. So we have calculated Z1 equivalent, Z2 equivalent, and ZF is 0. And what is the pre-fault voltage? So here we have to be careful. See, this time they have not asked pre-fault condition, but if they will ask pre-fault condition, in that case, we have to calculate this bus voltage. Here only we will do mistake. If they will twist the question, so we have to be careful. So while calculating the pre-fault voltage, we will take the pre-fault condition, and before the fault, let's say before the fault, this voltage voltage of this bus 1 will be 0.9 per unit. Okay. So for fault calculation, here we have to put 0.9. But since here they have told that like pre-fault condition are neglected, so bus voltage will be 1 per unit only. So what will be the final circuit? Here it will be plus minus 1 per unit. Here it will be J 0.12 and here also will be J 0.12. So what will be this current IA1? IA1 will be 1 divided by J 0.12 plus J 0.12. It will be J 0.24. So can anyone calculate what will be the value of this? 1 by divided by J 0.24. Can anyone tell?
Minus 4.16.
It will be minus J 4.16. Okay, so this is the value of IA1. What is the fault current equation? Fault current is IF is equal to minus J root 3 into IA1. IA1 is minus J 4.16. Can anyone tell the final value? So J square is minus 1. Minus 1 and minus minus plus, it will be minus something will come.
Minus 12.5. Minus 12.5.
No, root 3 into 4.16. How it will be 12? Wait, I will calculate it. Root 3 into 4.16. 7.2 I am getting. minus 7.2. Okay. So it will be, I think 166 will be here. So 166 if we'll put, it will be 7.21 minus 7.21. See, but in question here also we have to be careful. What is asking in the question? Magnitude of the fault current. We have to not keep the sign. Okay. Some people will calculate and put the minus answer, that will be wrong. So, like, we should not put the, like, fill in the blanks time question in hurry. We should read the question carefully. What is the final answer they are asking? We should put that. So, fault current will be, magnitude will be 7.21. So, this you have to fill in the that this type of question. Is it clear?
Please.
Yes, sir.
Yes,
Okay.
sir. Sir,
So, see, I am explaining
sir,
one thing here. 1 second. So, this is y minus. So this fault current equation for BC fault, phase B and phase C. Okay, 1 second. Let's say this is phase A, this is phase B, and this is phase C. So whatever this equation is derived, this is phase B and phase C. So this is the fault current equation minus J root 3 IA1. Okay. So if it is coming negative, means our fault current is flowing from C to B. What is the significance of negative current? Means fault is following from phase C to phase B. Okay. Now you can ask your doubt.
sir, I am not having doubt, sir. I am asking for the WhatsApp group for the NPTEL. You said in the lecture that there is some group of NPTEL. So I would like to join. If you can
If you
share the
anyone who want to
link.
join the group, they can share your WhatsApp number here in the chat box. I will tell the admin to add it there.
Sir, could you please share your mail ID, sir? I
See,
have personal doubt.
mail ID better. I am there in that group. Okay. See, mail sometime I will miss because so many other mails are also coming. So maybe I will miss. In group I will be there. So you can drop down your number here. Okay. Those
Yes,
who are
sir.
drop. Okay. Those who wants to, they can drop their number. Okay, I'm taking the screenshot. I will add this in the group. Okay, so thank you all. In next class also I will come up with some novel concepts. So we will learn some new thing. Okay, I will try to explain all the questions in short method so that it will save your time. Like, see, questions are already available on YouTube. So many things are available. So whatever content I am delivering, I am trying to deliver some new concepts such that it will be beneficial to you in the GATE exam. So thank you all. We'll meet on the next Monday.